Hello students, welcome back to a new mathematics program for grade 8. In this video, we are going to talk about factorization of algebraic expressions. Remember that this video is the third and last part of a series of 3 videos based on the chapter Algebraic Terms and Algebraic Expressions. In the first video, you learned how to calculate HCF of algebraic terms. In the second video, you learned how to factorize algebraic expressions with single factors. In this video today, I'm going to show to you how to factorize algebraic expressions with a compound factor. So let's begin with factorization of algebraic expressions. So students, let's see how to factorize algebraic terms with compound factors. But first of all, let's do a recap on factorization of algebraic terms with a single factor. Factorize ax plus bx. As you can see here, the letter x is common. So the factorization of ax plus bx is x into a plus b. Now this x, we are going to call it a single factor. Now have a look at this algebraic expression. A into x plus 1 plus b into x plus 1. As you can see here, the common factor is x plus 1 within brackets. So when factorizing, first you're going to write x plus 1 in brackets, followed by a plus b. So the factorization of a into x plus 1 plus b into x plus 1 is x plus 1 into a plus b. This x plus 1 is called a compound factor. Let's have a look at some more examples. 2a into x minus 3 plus b into x minus 3. The common factor here is x minus 3 within brackets. So we write x minus 3 in brackets first, followed by 2a plus b in brackets. M into m minus 1 minus 2 into m minus 1. The common factors are m minus 1 within brackets, so we write m minus 1 within bracket first, followed by m minus 2 within brackets. Now have a look at this algebraic expression. Ax plus bx plus 2a plus 2b. We have 4 algebraic terms in this expression. We're going to factorize this algebraic expression containing 4 algebraic terms. Have a look at these 4 terms. There is no common factor of the 4 terms, but we do have a common factor of the first 2 and a common factor in the next 2 terms. So we're going to call this factorization by grouping. That is, we are making 2 groups of 2 algebraic terms. In the first group, where we have ax plus bx, the letter x is common. And in the second group, 2a plus 2b, the number 2 is common. So we're going to factorize in 2 parts. In the first part, we are going to take x outside the brackets. And in the second part, we are going to take 2 outside the brackets. So we have x into a plus b plus 2 into a plus b. Now we are having an expression with the bracket a plus b as common factor. So we are having a compound factor of a plus b here. So the answer will be, we write a plus b in brackets first, followed by x plus 2 within brackets. Let's have a look at one more example. ab plus 2b plus am plus 2n. Since we do not have a common factor in all the 4 algebraic terms, we're going to make 2 groups of 2. In the first group, we're going to find a common factor, and in the second group again, we're going to find a common factor. In the first group, the common factor is b, and in the second group, the common factor is m. So factorizing these four terms in two groups, we have b into a plus 2 plus m into a plus 2. Now, this a plus 2 within brackets is the compound factor. So the answer is, we write a plus 2 within brackets first, followed by b plus m within brackets. Example 3. Again, we have four terms, but here we have a negative sign in the middle. Let's see what happened. We take two different groups, the first two in the first group and the next two in the second group. In the first group, we're going to find the common factor. The common factor is the letter n. And in the second group, the common factor is 5. Now, when we are factorizing these two groups, we have n brackets a plus x minus 5 brackets a plus x again. You have seen that the sign inside the bracket has changed. Initially we had minus 5x, but when removing 5 outside the brackets, the negative sign has changed into positive, because we do have a negative sign in front of the bracket. I have shown to you in the second video of this set of videos for this chapter that whenever we are having a negative sign in front of a bracket, the sign inside the bracket changes in factorization. So we have a common factor of a plus x within brackets. This a plus x within brackets is called a compound factor. So the answer is a plus x within brackets followed by n minus 5 within brackets. One more example where we are going to have a negative sign in front of brackets. There are two different groups. The first group we have 3a minus 3x, where 3 is common. And in the second group, we have the letter m as common factor. Since we are having a negative sign in front of m, you will see that the sign inside the bracket containing a and x, there is a change in the sign. The positive sign has changed into negative sign. Again, because we are dividing the last two terms by minus m. If we divide minus am by minus m, we have positive a. And if we divide positive mx by minus m, we have minus x. The common factor here is a minus x. So the factorization of 3a minus 3x minus am plus mx is a minus x within brackets followed by 3 minus m within brackets. Now there are some special cases where here we have 4 algebraic terms. We're going to make 2 different groups, but in these 2 groups we do not have a common factor. ax plus 2b, there is no common factor. bx plus 2a, there is no common factor. Now to proceed through factorization, we need to interchange the position of the algebraic terms. As you can see here, we have 2 terms containing x. We're going to group them together. Now we have ax plus bx plus 2b plus 2a. Again, we are having 2 different groups. In the first group now we have the letter x as common factor. In the second group we have number 2 as common factor. So we have x into a plus b plus 2 into b plus a. Now you know that b plus a is same as a plus b. So we can write it as x into a plus b plus 2 into a plus b. We have a compound factor here, a plus b. So the answer is a plus b within brackets followed by x plus 2. Let's see one more example where we need to interchange the position of the algebraic terms. Again, if you are making two different groups, in the two groups we do not have common factors. Like for the first group, pq plus 9, there is no common factor. But in the second group we do have a common factor 3. But we cannot proceed since the first group we do not have a common factor. So we are going to proceed by interchanging the position of 3q and 9. So we have pq plus 3q plus 9 plus 3. In the first group of 2, we have the letter q as common factor. In the second group, we are going to have 3 as the common factor because we are going to divide 9 and 3 by 3. The HCF of 9 and 3 is 3. So, factorizing these four terms, we are having q into p plus 3 into 3 plus p. You know that 3 plus p is same as p plus 3. So, we are proceeding with the compound factor of p plus 3 within brackets followed by q plus 3. Example 7. Factorize ab minus 2m plus 2b minus am. We are going to make two different groups. Now, in these two groups, we do not have a common factor. So we can interchange the position of minus 2m and plus 2b. Interchanging their positions, we have ab plus 2b minus 2m minus am. In the first group of 2, we have the letter b as common factor, and in the second group, we have minus m as the common factor. But in the two brackets that we have obtained here, we have different terms. That is, in the first one we have a plus 2, and the second one we have 2 minus a. A plus 2 and 2 minus a are not common factor. That is, we do not have a common compound factor. So we cannot proceed in factorizing this algebraic expression. Okay, so we are going now to interchange the position of two terms other than 2m and plus 2b. Okay, so we are going to interchange the position of minus 2m and minus am, so that we have this expression now: ab plus 2b minus am minus 2m. In the first two terms, the letter b is the common factor. In the next two terms, the letter minus m is the common factor. Here we have obtained two similar brackets. So we have a compound factor that is common to both groups. So we can proceed now, taking a plus 2 as the common factor, followed by b minus m. Let's take one more example where we're going to interchange the position of two terms, and we are not going to have the same brackets in the two groups. Since we cannot proceed in factorization, we are going to interchange the other two algebraic terms. As you can see here, we are taking the plus 3p at the end. So we are having ac minus 3c minus ap plus 3p. In the first group, we have the letter C as common factor. In the second group, that is the last two algebraic terms, the letter minus P will be the common factor. Now we do have a common compound factor, which is A minus 3. So the factorization is A minus 3 followed by C minus P. These are called special cases where we interchange two algebraic terms, still we cannot proceed in factorization. So we have to move back to the interchanging of the algebraic terms so that we can have common compound factors. So students, now I'm going to give you some exercises for practice. Factorize the following. If ever you are having any difficulties, you can always seek the help of your parents or teachers. Students, if you want to have some more information on this chapter, you can consult these websites. So friends, in this chapter, you have learned how to factorize algebraic expressions with compound factors. So students, this program ends here. Remember that this video is the third and last part of the chapter Algebraic Terms and Algebraic Expressions. In the first video, you learned how to find the HCF of algebraic terms. In the second video, you have learned how to factorize algebraic expressions with single factors. And in this video, you have just learned how to factorize algebraic expressions with compound factors. So students, see you soon for another chapter. Till then, goodbye.